So hello everyone, here's another problem related to improper integral. In this problem, I ask you to evaluate this improper integral algebraically. So the process, the very first step should be very similar to numerical estimation process. Okay, so you want to rewrite this improper integral in terms of limit of definite integral. That is, the limit as n go to negative infinity of the definite integral from n to negative 5 of 8 over x cubed dx. For the numerical estimation, you can stop right here and you create the table using the calculator to fill in the values of the evaluation of the definite integral. But for the algebraic manipulation, you need to continue the process. That is, you need to evaluate definite integral. Right? Whatever you got, then you let n approach to negative infinity algebraically. Okay. So for this definite integral, you treat this as the regular definite integral you have done before. Right? So for this definite integral, I see that I have an 8, which is a constant. I can bring the constant out of the integrals. So I have limit as n go to negative infinity of 8 times the integral from n to negative 5 of 1 over x cubed dx. Okay, so the next step is that I'm trying to find the antiderivative of this definite integral. Okay, and the antiderivative of 1 over x cubed is not very obvious, but you can change that to a power function and then you can use the power rule. Right? So to rewrite this definite integral, I have the limit as n go to negative infinity of 8, and then the definite integral from n to negative 5 of x to negative 3 dx. Right, to save this, because I have 1 over x cubed, right, I want to change the power function. I bring x cubed from the denominator to the numerator. That's why I changed the sign of the power. From here, you can use the power rule. Right, so I use the power rule. I have x to negative 3 plus 1 divided by negative 3 plus 1. And by the fundamental theorem of calculus part 2, you have this vertical line. That means evaluate this antiderivative at n and negative 5. Okay, so next step, this is what you got. Limit as n go to negative infinity of 8 times x to negative 2 divided by negative 2. That's what I'm simplifying. Then I'm still evaluate this between the at n and negative 5. So at this step, I'm going to simplify this expression a little bit. So 8 divided by negative 2, I have negative 4. And I'm going to switch x to negative 2 to get the power to get the positive power. That is, I'm going to bring x to negative 2 down to the denominator. Okay, so this is what I get. So negative 4 times 1 over x squared evaluated between n and negative 5. Now, I'm going to substitute negative 5 into the place of x and capital N into the place of x. That's the second part of the fundamental theorem of calculus. So from here, I use the fundamental theorem of calculus part 2. I'm going to substitute negative 5 into the place of x and capital N into the place of x. This is what I got. I got a limit as n go to negative infinity of negative 4 times 1 over negative 5 squared. Then subtract negative 4 times 1 over n squared. Okay? And then I simplified this to expressions. So I get limit as n go to negative infinity of negative 4, and then 1 divided by 25. Then this one is negative with negative become positive, so I have positive 4 over n squared. So the first term, I don't have anything related to n, so I'm okay with that, right? So I'm going to write is become negative 4 over 25. But for the second term, I have 4 divided by n squared. There's an n involved, right? So as n go to negative infinity, you put n in here, right? So n negative infinity squared become positive infinity. 4 divided by an infinity. If you go back to the note in 6.1, you will see that this term will approach to 0 as n approach to positive infinity or approach to negative infinity. Okay, so I'm just going to write like this, and you left with negative 4 over 25. You can just leave it like this. We're okay with fractions, the answer in fraction, or if you want, you can use the calculator and estimate this value to have negative 0.16. And